Dear students, I am your Joshi sir. I would like to teach very important informations about the chapter called electricity. It is a branch of science, or you can tell physics, which deals with study of charges. Charges, remember there are two types. One is static, means stationary. And the one is a current electricity. Here for standard 10th, we are going to learn current electricity. That is a flow of charges. To know about this chapter, we must know some symbols used for some terms. Like current, we say I. For charges, we say Q. For time, we say T. For resistor or resistance, we say R. For length, we say L. For resistivity, we say rho. Like that, so many informations I am going to give you. That is why in the beginning of the chapter, remember we have explained everything else in detail during our vacation classes. Here I am going to cover the chapter by giving you some informations, more informations. Q by T is amount of charge. Here I have written flow of electric charges in unit time is called electric current. Or else, when time is written in the denominator, we use the word rate of flow of electric charges through conductor. This is the definition. Whenever they ask you the definition, define. What do you mean by? You have to write inverted comma. So that while checking your paper, it should be perfect and neat, a discipline. And you have to underline important wordings like flow, charges, conductor. Important words. When you write one C and one S, according to mathematics, 1 by 1 is 1. That is why when 1 coulomb of charge flows through the conductor in 1 second, we say 1 ampere. They may ask you the question, define 1 ampere. Don't by heart. You remember 1 upon 1. 1 coulomb per 1 second. Further, it is general electric circuit diagram. Bulb, battery, group of cells. Don't draw only 2. You can draw more than 2. 3, 4 sufficient. Further connected to switch. It's closed. When you don't write a dot there, it is open. When you write this dot, it is closed. Further connected to ammeter. Measure the flow of current. It's a device. Remember one trick I would like to give you. Battery and ammeter should be same connection. I mean negative to the negative. You remember. That is why same. Don't write in the exam same. In the notebook. And ammeter to further, you can say positive. Here to positive. Current always flows from positive to negative. It is universally accepted. Not from negative. You have to show this. If you don't show this circuit diagram is incomplete. You may get the marks or you may not. So always you must mark what you call I. Next, from one end to another end, we use the word PD, potential difference. Means work done in bringing charges. Amount of charges from one end to another end. One end to another end. We use the word PD. So another formula is V equal to W by Q. To remember this, I have written here one trick. When you close W, V into Q. When you close V, W by Q. When you close Q, W by V. So that is why it is very important. Now, if you come to this diagram, one of the best scientists, Ohm, he wanted to know the resistance of the conductor. That's why it is written X. You see the connection of the wire, it is taken to the positive. Negative pole from which wire is connected to the switch closed and then to emitter. Same, see here. Positive opposite is negative. Voltmeter. Remember always voltmeter is connected in parallel. Always. Because remember it has high resistance. When there are two ways for the current to flow, remember if it is a low resistance, it will drag maximum current. Then you will not get required current for the device to operate. So that is why voltmeter is in always a parallel, because this voltmeter has high resistance, means it allows less current. Required current will flow here. So he told at constant temperature, potential difference and current are directly proportional. We say potential difference is directly proportional to electric current at constant temperature across the ends. He did one experiment by using rheostat. He adjusted the current. He noted down the reading in the voltmeter. Again changed the current, value of the current by moving, slide contact in the rheostat. Again he noted down the voltmeter reading. In this way he took set 1, set 2, set 3, set 4 like that. Even in the practical you can do it. He found V by I ratio as constant. When he got V by I as a constant, he wrote that constant as R. Resistance. Resistance means opposed to the flow of current. So that's why I have written more is the resistance, less is the current. You remember the symbols. You can write by own the sentences. Here, this is one way. This is about Ohm's law. V equal to IR or V by I equal to R. So to remember that, this is the trick. Next. Resistance and length and area, there is one more relation. What he told, as the length increases, resistance also increases. Means flow of current is less. Area is more, resistance is less. Oppose is less. It allows more current to flow. Together, it is written as R proportional to L upon A. When you remove proportional sign, what you have to write is equal to. Equal to, here you have to write constant. They took rho, R-H-O as a constant. The resistivity is equal to resistance of 1 ohm only when length is 1 meter and area is 1 meter square. Then resistivity is a resistance of 1 ohm. But SI unit of resistivity is not ohm, it is ohm meter. R ohm, rho as it is, length meter, area meter square. 1 meter cancels by cross multiplication. Ohm meter is equal to rho. So this is a starting information about what you call this chapter. We continue again for the next. Okay.